Okay, I think we can get started. I have a lot of slides, so I'll get started a little bit before 1:15. Hi everyone, my name is Erik Hellman. I am a freelance software developer from Sweden. I usually work on Android, but lately I've also started doing web development as well. And this is why I'm doing this talk about progressive web apps using Kotlin. If my voice would happen to disappear during this talk, we should all blame Jake Wharton because he was the one who made me drink more beer yesterday than I was supposed to. Okay, so let's move on. So this talk is about the actual cross-platform where we actually write apps that run everywhere. That's the intention of the progressive web apps. It's writing web applications that can be installed as native applications. So currently, you can do this, or you can install quite a few of these already. You basically go to the websites you have and you can install them. And this is an example of Twitter, Google Maps, and Pinterest that you run as installable web applications on your desktop. The same thing, you can also install them on your Android phone, etc., and all other platforms usually that supports PWA today. So the good thing there is that the difference between the progressive web app, we're going to go into details there later, but it enables you to actually write apps that feels and looks like native applications. We do this in JavaScript, or at least that's the runtime where we got to work with. And anyone who here works with JavaScript on a daily basis? Yeah, I guess so. So you also know that there is a lot of opinion about JavaScript, whether it's good or bad. It is what it is. It has its issues, but so does every other language. But over the years, there has been a lot of alternatives to JavaScript. You write in one language and it transpiles over to something else. Anyone remember CoffeeScript here? Anyone used that? That was great. We can't forget GWT also, awesome. Anyway, there's a lot of these, but over the time, kind of like TypeScript kind of won this one, became the de facto language to use instead of JavaScript. And there are several reasons there. TypeScript is a great language. It has features that make it work really well for targeting the web platform. Because types, they are awesome. They're great. And this is why we like the strongly typed languages, because they help us to scale up projects. Now, the way it works with the TypeScript is in many of the node libraries you can find, but also in the web platform itself, you can find files that end with d.ts. It's a TypeScript type definition for that library or for that API. So the entire DOM API is available as a file called like this. So this is the entire type-safe definition of the JavaScript API, which makes it works inside your favorite IDE and stuff like that. And this is great. So we should be able to use this with Kotlin, right? Kotlin also a strongly typed language, pretty much the same as TypeScript. So we should be able to do something like this. This is an example for using the UI framework LitElements, which builds on top of web components. And this is the TypeScript code of that one. So we should be able to do the same thing in Kotlin with something like this, almost. That's the goal. But as we all know, JavaScript can be a bit weird. You can do this. This is a valid JavaScript thing. It either returns a number or a string. Now, TypeScript deals with this in a great way, using something called union types. Anyone here familiar with the union types? Yeah, cool. You all know what I'm talking about. But we don't have union types in Kotlin. That doesn't exist there. So this is the challenge. And this with union types is nothing strange. You take again this LitElement framework that I showed you earlier. It actually has this in its API where it returns a union type of either this one or the other one. And this is the thing we have to work around. This is one of the challenges with using KotlinJS to target the JavaScript platform. So how does it work? Well, you set up your build script first. We use Gradle. You can use Node as well, npm and all that as well. But I'm going to talk mostly about the whole Gradle build system, or use the Gradle build system here. So you basically set this up. You define the Gradle plugin you're going to use for your project, and you define your repositories, and then you have the Kotlin configuration where you say target this, and with this you want to have Node.js support because you might want to use an existing JavaScript library, and you're targeting the browser. The other alternative is targeting Node, so you run on the server side. And then you define your dependencies. So nothing strange there if you are used to Kotlin projects before. So we write our first super simple application where we add a click listener to a button. So the standard library for Kotlin.js has already a bunch of definitions that matches the DOM API. So we got the document, we can call document query selector, pass in a CSS selector there. And since that is nullable, it can return null. We can do an early return if we don't get that one, and then we add the event listener. And for anyone here thinking that we should be able to place that lambda outside there, we can't because there is an optional third parameter. So it doesn't really work in that case. So we run this through the Kotlin compiler, and you get this. Everybody can read this, right? Yeah, so it's a lot of code. Of course, it's a lot of code. Let's extract all the unnecessary stuff. So it defines the main function. And you can see that the first thing is it defines the lambda. That's the click listener that we added. And then the actual main function that we wrote, where it builds up the same code that we had before. And the key to the thing here is the final thing there, where it actually calls this main function. So when you have your typical JavaScript file and you include that one, it will evaluate whatever is there. You can just call functions from the root scope of the script, and that will happen. But we don't have that in Kotlin. So what Kotlin.js does is that wraps everything here and then calls the function itself. So progressive web apps. What's different with that one compared to like regular web applications? Well, it's more of like a philosophy around it. So Google has this very nice, I stole these images from Google as well, nice page where they explain it's reliable, fast, and engaging. But it's more about reliable. It should work regardless of your network conditions. So if you're offline or you have a shaky network, it should still load and show data or show UI. It should be fast. It should react as fast as native applications. So the user shouldn't notice that they are actually loading a web page, so they shouldn't be a like big blank page at first. And engaging is that it should behave like a native application. And a lot of this already works today on your desktop, whether you're running Chrome or Firefox. We've got some other experts here in the room about progressive web apps that can tell you more about that. But the key components that I'm going to talk about at least is this. It's a web app manifest, which is just a JSON file. You need a service worker. You usually do need a service worker in order to get this offline behavior. And then we have the actual web UI, which is just regular HTML and stuff like that. So the web app manifest, super simple. This is all I'm going to mention about that. It's a JSON file which defines the icon, the name, etc., etc. And once you have this one, it becomes sort of an installable application. It works like this. So if you go to maps.google.com, you open the menu in Chrome, then you see the install Google Maps, and it will install it on your desktop. And it will look like that instead. And then we'll interact with your desktop as every other native application. So if you do Command Tab and switch to other windows, it shows up in that list. So it's not just a tab inside your browser. Service worker, a little bit more complicated. So the thing is, you have your first HTML page which is loaded in the browser. That one includes a script, your application, main.js. And in turn, the main.js loads the service worker. So something like this, HTML. And then in our main.js, if we would write this in JavaScript, it would look like this. We call navigator, service worker, register, and we pass in the URL to that service worker script. And then, because this is promise, you do then or catch to see if everything worked out all right. So in the service worker then, we call self add event listener on the install and the activate events. So install is basically the first thing. Now this service worker got installed, and activate is when it becomes active and can do stuff. And then we can do things like we can intercept all the fetch requests, and we can either deliver local data that we have stored in either the IndexedDB or the cache or the local storage or wherever, or we can decide that we go out on the network and fetch it instead. So it basically works like a sort of a proxy. So the idea behind that is that we have the service worker running between your web UI and whatever it needs to load to show data. So the service worker can make these decisions for you. So how you decide this is all up to you. Different caching strategies. Should we go to the cache first or network first, or and how should we fall back when something goes wrong, and how should we behave when it's offline? So it's all up to how you implement that. Now, in KotlinJS, how do we do a service worker? Well, again, we need a main function, so we add an event listener to the load event when this script is loaded, and everything is loaded in the main page. And then we say window, navigator, service worker, register. It's basically the same code. So we start there, and yeah, so all that works out of the box. Now, inside the service worker, the other script, basically, you want to install it and you want to add caching support for offline stuff. So you use the same API, you got the same API there, but the problem is that in order to reach the scope, the service worker scope, the service worker global scope, you need to use self. And that one isn't defined in the KotlinJS library, because self in the KotlinJS, in the JavaScript world, is either the window or whatever service worker scope or worker scope you're currently running in. So it's a union type. So you need to define it in this context as what it is for you here. So here you have external val self service worker global scope. And then KotlinJS will assume that there is a global variable called self that is of that type. And here we do event wait until, which means that don't proceed with installation until you do this thing, and this thing in this case is basically open the cache and add all this URL to the cache. So cache these things. Also, you see that we need to cast the event to an install event, because the event listener doesn't know what type of event it is. So whatever event listener you have, you always have to do that event as and the specific type. Otherwise, it's just a generic event type. Yeah, so this one, the reference to the service worker scope. Now, so how would you implement the actual offline cache then? So we add a listener to the fetch event. Again, cast it to a fetch event. And the fetch event itself has a request. We take that request, we pass it into our cache and say, can we find a matching resource for this one? And if it does, if that one is not null, I'll return that cache response instead. Otherwise, call fetch out to the network and get that data. So this is like cache first strategy. So if all your data would be static and will be downloaded, once the application has run once and loaded the resources, it would just use the local stuff. So we usually write applications that call some kind of HTTP API, whether it's REST API or whatever it is. So how would we do this with KotlinJS in an efficient way? We could use the fetch API and leave it at that and parse the JSON and stuff like that, but it's not very efficient and it's not very Kotlin idiomatic. So we're going to use two libraries. There are going to be more talks this 2 days about these two libraries. So I'm just going to touch upon the very basic in the context of KotlinJS. So you add the plugin for the serialization library, and then you add the dependencies for coroutines and for Cater client, the JavaScript version of the Cater client. So our API is this one. It returns a list of kittens. So it looks like that, very simple JSON thing. So we basically have two objects here. We have the root object, which is the root response object, and then we have an array of kitten objects. Using the data classes in Kotlin, we just do this. We define the data classes, and we add the serializable from the Kotlin X serializable library. And the plugin will now generate the JSON adapters automatically for you. So any of you who have used Retrofit before, it works Retrofit and Moshi before, it works in the same way. But this is the cross-platform Kotlin library that works also for JavaScript. So if you want to test this, basically you can get an object in, you call the serializer on the class, a static function there, and then you create a JSON object, and then you can do JSON stringify, and you can take the data and you can call JSON parse to get back the object. So typical serializer library, and you get this nice type-safe integration with your backend API. Now, it doesn't stop there, because the HTTP client from Ktor, the JavaScript version of that one, is really nice to work with here. I actually prefer this one for all Kotlin development these days, because before Retrofit and all these others, because it's super simple to work with. So you create an HTTP client, you tell it you want the JavaScript version, and then you say, install also the JSON feature for this HTTP client. Now, if you want to call the API, we got the URL there, just call client get and the URL, and I've been explicit here in specifying the type. So now the JSON, the Kotlin X serialization library will kick in here and assume that you're getting a kitten response and do the deserialization for you. So now you got a nice way of fetching data in a type-safe way. So you had coroutines there. You saw that we have a suspend function there. That's because Ktor builds a lot upon the suspending function and coroutines. So how do we do coroutines in Kotlin.js? Well, JavaScript has the concept of promises. So before I used then and catch on the register call here, or the register call when you register a service worker returns a promise. But in JavaScript instead, I can define the function as an async function, and then I just add await in front of the call that returns a promise, and it will wait until that happens. So that's how we would do it without using the chained then and catch calls. And you can catch exceptions and stuff like that. So it's pretty much the same thing that we do with suspended function and coroutines. So there is a wait function that is an extension function on promise in the Kotlin.js world. We just define our function as suspend, and you get the exact same result. The extension function in Kotlin.js looks like this. It's basically a suspend cancelable coroutine that takes a continuation. So if you're unfamiliar with coroutines, there are many great talks about that. But when we get the unfulfilled call, we call continuation resume. And if something goes wrong, resume with exception. So it basically wraps the promise API in a nice way like this. So finally then, the UI part. So we covered how to set up the service worker, how to make network calls and do deserializations, and a little bit about how the coroutines work. So what you do, if you want to just work with HTML, sure, you can just create a string and return that, or use the DOM API directly, but it's not very efficient. But there is a very nice DSL called Kotlin X HTML. That one allows you to write HTML code with Kotlin code. So has anyone used this one already? A few of you, so yeah. Okay, so basically we start with getting the root node where we want to add our HTML, and there is an extension function on HTML element in Kotlin. And what we do there is just append, and then we have Kotlin functions that match all the standard HTML elements. So H1 will create a H1 element. The tricky thing here that might be new for some of you is the unary plus operator in front of the string. That one basically means append this string to this element. So it just puts the text inside there. I'm not sure if I really like that one, or if I would like to have like an explicit function called append or something. But well, this is how it works now. So it feels a bit unfamiliar if you're not used to that one. If you want to have a regular image, you do like that, and most of the attributes to these tags are available as inside here also. There's also like if there's something missing, you can also define a raw string and append that one, and it will just evaluate what you have there as HTML and add it. Now, this is regular Kotlin code, so this will be the result of it. This is regular Kotlin code, so we could do like this. We have an array, and then we call append, and we create the unsorted list element, and then we iterate over this one, and nothing strange here. We check which index we have, and then we add the CSS class based on whether it's even or odd index for that one. So you can add the CSS classes here as well. If you want to add a click function on each of these elements, you can do that. Currently here it's empty. And then we just add plus kitten here, which is the string from the list up there. So there is nothing really weird about this in a Kotlin way. The only downside with this one is that you would work directly with a DOM, which isn't very, very efficient. So you would like to have a UI framework. And currently, the only UI framework for the Kotlin.js that is ready to work with, except for this just working with raw HTML, is React. So JetBrains has created a React wrapper. So you just add these dependencies, and these dependencies look a little bit weird. You see the npm there. I'm going to explain what that means in a moment. But you add these dependencies, and it's basically Kotlin wrappers on top of the React APIs. It works like this. You have a class called rbuilder, and you just keep defining extension functions on the rbuilder class, which will return HTML. So instead of writing JSX, you use the KotlinX HTML library, so you don't have to mix raw HTML in your Kotlin code. Then you finally call render, pass in the element that you're going to do there, and call the extension function that matches the root of your application. And this would then be just work like regular React code. There is also another option, which is called the create. You probably have heard of the create React app script you use to set up a new React project. They have a Kotlin version of that one, and this is when you would work with the npm package manager and all of those things. So you just install create React Kotlin app as a global npm dependency, and then you run create React Kotlin app instead of just create React app. Give it a name, and then you're up and running as standard Kotlin, standard React application. Now here you're missing out. You're not using Gradle to bundle all these things, so I'm not sure if this is the best way to use Kotlin for developing web applications, but it's there. So npm packages. How do you add dependencies to JavaScript libraries? How do you use an existing JavaScript library in Kotlin? So, since you're JavaScript developers, I assume you know what the npm packages are and how to install them. And you can use the same thing in Kotlin.js, even if you're having Gradle as your build system. So we'll take this library that I recently used, the JS-zip library. Basically, JavaScript library for reading, loading data, or writing data to zip files. And you would wonder why we would want to do that, but yeah, there are reasons. Probably if you want to read the content of a zip file, or you want to generate a zip file to the user in your application, this is the one you want to use. Now, this one, JetBrains hasn't created any wrappers for this one, so we need to create wrappers for this one. But first of all, we also need to import it. So in our Gradle script, we need to make sure that the target, in the target section, we call Node.js. Now it will add support for npm libraries. So we can do implementation npm and then we just specify the name of the library and the version. I think the version is optional, so if you don't use that one, it will always fetch the latest. But you should specify that one so you don't get longer build times. So that's how easy it is to import that one. It will use npm in the background to do this. Now, you need to define the API yourself in Kotlin. So the API is completely in JavaScript. There is no type definition from TypeScript that you can use right away or try to convert. So you need to define it yourself. If we go back here, you see that there is on the JS zip object, there is a function called file. There's also load async, and each zip object has also an async method. So those are the ones that we need in order to load a specific file inside the zip library. And what we do then, we use the external keyword again. So we say we have an external class called zip object. That one will have a function called async, which will take a string and return a promise. And since we don't really know exactly what's inside that one yet, because it depends on the string you type in there. So if you say blob, it will be a blob. If you say array buffer, it will be an array buffer, and so on. So we need to use any there. It's a promise of any. Now, and then we have the JS zip class, and we define the file function taking a string. But that one we know that will always return a zip object of a promise. And then we have the load async, where we pass in data as an array buffer. We know that we will get a JS zip back. Okay, so we define the API in Kotlin. We don't need to define the entire API, only the things you need. That's the convenient thing about it. So using this one, so I create the JS zip instance in Kotlin, and then I call fetch to fetch my zip file from the server, and I call array buffer on the response, saying, okay, get me the array buffer of the body, and then I call load async on my JS zip object, which will return a promise of a zip file. I'll call file, passing in the file name that I want, and that one will open up, and then I say, now I got that one, and then I finally call async as a blob, and I get a promise as a blob instead. And then I can create the URL object and pass that one into an image and show the image that was previously inside the zip file. Now, this doesn't look super fun because it's a lot of chaining then calls. So you can use coroutines, of course, to do this, even though you use an external npm library. So this is great. This is the way you probably go if you're using an existing JavaScript library, importing that one. But what happens in the cases where you find a type where you cannot use, you can't really convert it to Kotlin easily. It's a union type or something like that, or it's just really hard to map it. So Kotlin has a dynamic keyword. And dynamic keyword will it's kind of like the magic last resort. I don't have any better explanation. So remember this one, TypeScript thing where it returns a union of number or string. So how would we implement that in Kotlin? How would we define this function? Well, what we do, oh, I'm missing a slide here. Nice. So what we do in the external definition we have, we add a dynamic as a return value. And that means that when we call this one, if the TypeScript example code that will return dynamic, we get the result, and it's of type dynamic, which means it can be anything. And now we can cast that one to a string if we know that it is a string. So that would work. But the fun thing with dynamic is that you can call pretty much anything on it, and the compiler will say, sure, because we just convert it to JavaScript. And yeah, it's a great way to shoot yourself in the foot multiple times. But yeah, so this is because we need this one in JavaScript, right? We don't have union type, so that's one example. And it might be a very complex API that you're trying to map, and you say like, okay, finally I know I will get this thing here, and that will be a type. So dynamic to the rescue, sort of, for these things. Now, something new that came very recently to Kotlin.js is called Docut. It's experimental. I don't mean it's very experimental. So this is definitely not ready for production use. You enable it by opening your Gradle properties file and saying generate Kotlin extensions true. What this one will do is add a task to your Gradle called generate externals. And that's basically what it does. So what we have here is index.d.ts, and Docut only works on the TypeScript definitions, the files, the type definitions files for npm libraries. So there needs to be a .d.ts file somewhere in that library. So it will take this one and read it and say, okay, we got a function that's called leftpad that has either a union type of string or number, length, which is a number, a nullable parameter that can be a string or a number, and it returns a string. The good thing with having union types as function parameters is that we can map that to Kotlin. And the way Docut will do this for us is basically generating this code. So this is all the permutations of the leftpad function in Kotlin. It will automatically generate those for us. And this is great. So as long as the developer of the JavaScript library has type definitions defined and added them to their package JSON file, Docut should be able to pick this one up. Now, it doesn't work completely. There are some gotchas there. And if you try it today on a larger library, more complex library, it probably will fail for some reasons. But at least you can see this code generated, so you can see that they have come a long way, actually. Okay, I am very fast. So is Kotlin.js ready for production use? Well, depends. Some things work really great. Other things are a little bit awkward to use. The current build system will output one single JavaScript file. So if you're going to use the service worker, you have to find a way to work around that one. I excluded my very hacky solution here because I think that JetBrains will fix that soon, so you can actually output a separate service worker JavaScript. You could do that using 2 separate modules, but then you get a large code base because you duplicate a lot of code. Summing up this thing. JavaScript output when using Kotlin.js can be very big. This can be an issue, but it could also be fine. Might turn out not to be so much. But also, of course, JetBrains is continuously working on this one, so I expect that to reduce the output a lot in the future. There is also something called dead code elimination that kind of like does a tree shaking and removes unused code from the JavaScript output. There are Kotlin wrappers for the HTML parts, and the Cater client is really nice to use, and the serialization library is nice to use. But a lot of the DOM API doesn't have these nice Kotlin wrappers. And if you're using an existing JavaScript library, you probably want to add your own Kotlin wrappers on top of that to make everything nicer to work with. So there are some more Kotlin wrappers needed. The build system is almost completely undocumented at the moment, very much because they replaced the old build system for Kotlin.js with something new just very recently. But if you are on the Kotlin Lang Slack, or if you go to their support page, you can usually find help there. Something I'm missing is like splitting up the code properly in multiple parts, so that service worker doesn't become so awkward to work with. You can do it today with a single file, but yeah, this is something I'm waiting for. But overall, everything looks really, really promising. And I think it will be a nice alternative for those of us who prefer Kotlin over TypeScript, or where you have a large project where everything else is Kotlin. So it looks very promising. We're almost there, and for a lot of the cases, it already works fine. Now I'm gonna do another recommendation also today at 1 o'clock. There is a talk about the state of Kotlin.js. I think that's more going to focus on the actual build system and how to use that one and set up your project. It's a little bit different focus from mine. There is also another talk tomorrow, more full stack talk about where they talk about Kotlin.js. So if you're more interested, go see those. Now I'm going to do as my cat. I'm going to chill out for the rest of the day. So thank you very much for having me. We went really fast, so we have time for questions. But thank you, and remember to vote.